In the second part of cyclic quadrilateral and its properties, we shall start with alternative method of proving that the opposite angles of a cyclic quadrilateral sum up to 180 degree. The first method has already been described in first part of cyclic quadrilateral. We shall also discuss one or two other properties which we shall come later. Here is the alternative method of proving that the sum of opposite angles of a cyclic quadrilateral is 180 degree. To do that, we shall use the angle sum property of a triangle. We know that the sum of the angles of a triangle is 180 degree. We are focusing on the angle B and D to start with. So we join vertex A with vertex C to make a triangle. Now let us concentrate on the triangle ABC. We know that angle ABC plus BAC, that is this angle, and angle ACB, that is this angle. Together, these three together makes 180 degree by the angle sum property of a triangle. Now, if we can prove that this angle plus this angle is equal to angle D, then it will be easy to come to the inference that angle D and angle B sum up to 180 degree. Why? Because these two angles plus angle B is 180 degree. Now let us show this image. What we have done? Same way we have joined angle A with angle C, and this is the triangle we have got ABC. Now to prove what we wanted to prove, we have to join vertex B with vertex D also. Now consider this chord BC. BC has subtended an angle BAC, another angle BDC on the opposite segment. This is the minor arc. These two angles are subtended by the chord BC or the minor arc BC. So these two are equal. We know the angles in the same segment are equal. Next, we consider this chord AB. If we consider this chord and this minor arc AB, then it has subtended an angle ADB and another angle ACB in the opposite segment. So these two angles are equal. So what we have got? This angle is equal to this because this is the chord and these two are subtended angles, and this angle is equal to this because BC is the chord and these two are subtended angles. Now if we add these two, it will be equal to angle D, and if we add angle B with angle D, it will be 180 degree because we know the angle sum property. This angle and angle B together forms 180 degree. That is the alternative method of proving the key property of cyclic quadrilateral, that opposite angles are 180 degree. Same way we can also prove angle A and angle C add up to 180 degree. Let's check it with a tracing paper whether the opposite angles add up to 180 degree. We place a tracing paper here and draw angle B. Trace angle B on the tracing paper. This is our angle B. Now we are placing on this side, and this is angle B and this is angle D. We shall trace angle D whether they form one straight angle. So our angle D is this one, and this is our angle D, and you can see together these two angles together forms a straight angle. So angle B and angle D together make 180 degree. Next we shall prove that the external angle of a cyclic quadrilateral is equal to the opposite internal angle. The proof is simple. We know that opposite angles of a cyclic quadrilateral add up to 180 degree. So angle A and angle C here makes 180 degree. If we extend the line segment BC to E, we are getting an external angle DCE. And because it's a straight line, we know this angle plus this angle makes a straight angle, that is 180 degree. We know this angle and this angle is 180 degree. This is a common angle. So DCE, the external angle, is equal to BAD, the opposite internal angle, and thus it is proved. Now let's check this with a tracing paper. We place the tracing paper on angle BAD Now place the same angle on DCE to check whether they are exactly same. And we can see the angle exactly matches with angle DCE, which is the external angle. And angle BAD is the opposite internal angle. So these two angles are same. Lastly, we shall explain this interesting image. We can see a picture of a bow tie. I don't know if the children understand what is a bow tie. Bow tie is a tie of this shape worn in the party. Not the tie you wear in the school. It's like a bow. ADBC looks like a bow. And the angles A and B are same, and angles D and C are same. If we try to show the analogy with the bow tie, this angle is same as this angle and this angle is same as this angle. Let us prove that. First look at this chord DC. It has subtended two angles on this segment, DAC and DBC. And we know the angles in the same segment are equal, so these two are equal. We use a tracing paper to just to show that these two angles are equal. So this is angle A. You can see it's an angle A, and we trace the angle. Now we superimpose this angle on angle B. And we can see that it exactly matches with angle B. So angle A and angle B are same. Same way, for these two angles, we shall take the chord AB has subtended an angle ACB and ADB in this segment. So these two angles are again equal because they are in the same segment. Place the tracing paper and trace the angle ADB. And now if we superimpose the same angle on angle ACB, we can see that these two exactly match with each other. So these two angles are equal. That is where we get the analogy of a bow tie. We may name this bow tie angles.